Today we are looking at this digital circuit that combines a 4-to-1 multiplexer and a D flip-flop. Let's break down how the output Q behaves based on the values of the select lines S0 and S1. D0 is connected to Q, the flip-flop's own output. D1 is connected to Q prime, the inverse of Q. D2 is connected to S1 through a NOT gate. D3 is connected to S0, the select line itself. And the Mux output goes straight into the D, input of the flip-flop. The flip-flop is edge triggered, so whatever data is at D will be latched into Q on the next clock pulse. Let's begin the step-by-step analysis. Case 1. When both select lines are 0. We are selecting D0, which is connected directly to Q. That means we are feeding Q right back into D input. So on the next clock edge, Q just stays the same. For example, so let's say Q is currently holding a 1. That 1 loops back through D0, passes through the Mux, and comes right back into D input. On the next clock tick, the flip-flop sees a 1 on the input, which is what it was already holding, and just keeps holding that 1. Same goes if Q was a 0, it just stays 0. So if we go back to our answer choices, and we are asked what is the state of Q when S0 and S1 are both 0, the correct answer is no change. Choice C. By the way, if you like what you are watching, please hit the like button and also subscribe to the channel if you haven't done yet. Now back to the video. Case 2. Let's change S0 to 1 while keeping S1 at 0. That gives us a select combo of 0, 1, so D1 gets picked. D1 is wired to Q prime, the complement of Q. So on the next clock, Q will flip to the opposite of what it was before. It toggles. So if you are picking an answer for this case, it would be unknown, unless you already know the current state of Q. Case 3. Now let's switch it up. S0 is 0, S1 is 1. That points us to D2, which is coming from the output of a NOT gate. And that NOT gate is inverting S1 to logic 0. So we are feeding a constant 0 into D input of the flip-flop, meaning on the next clock pulse, Q will be reset to 0. So here, the correct answer is A. Case 4. Finally, with both S0 and S1 set to 1, we select D3, and D3 is connected to S0, which in this case is also 1. That means we are feeding a 1 into the flip-flop, so Q becomes 1 after the next clock edge. Therefore, the correct answer here would be B. And that is the whole analysis. This kind of circuit is a great example of how we can control a flip-flop using just a few logic lines and a mux. Hope you find this helpful. Thank you for watching, and always stay curious and keep building.